All right, on this last example, they're giving us a function that's graphed here, and it's a transformation of this parent function,
y equals 2 to the x.
Well, if we were to graph that parent function 2 to the power of x, it would be an increasing function. We would get 0, 1, 1, 2, 3, 8, and so forth. But we know it's not increasing, it's decreasing. So all of our x values have changed their signs. In other words, it's being reflected across the y-axis. So the first thing we know is that that exponent needs to be a negative or opposite of x to show that reflection. So if we focus on what our original is,
if we were to reflect these across the y-axis,
we would be here and here. Since they've given us this point and this point, I'm only going to focus on my 0 and my -1 at this point. Again, these 2 points right here. We're at a y value of 1 and a y value of 2. The frustrating thing is we know that our horizontal asymptote would originally be at y equals 0. But the graph that's being shown looks like we have a horizontal asymptote at y equals 3. So we know eventually we're going to have a shift of 3, but this is what occurs last. Remember, the last thing you do is a horizontal or vertical shift. If we just shifted up 3, we're still going to be, up here somewhere. We're not going to get to those points. So that means there is some sort of stretch that occurred. Let's kind of work backwards then. If we know that graph has been shifted up 3, let's shift it down 3 to see what our stretch would look like. If we moved this top left orange from -113 down 3, we would be here at 10, and our 0, 8 would be down here at 5. Okay, so that's what it would look like before that shift of 3. Well, I have a value here at 1 and a value here of 2. What would we need to multiply to move those 2 points of a y value of 1 and a y value of 2 up to a y value of 5 and a y value of 10? 1 times 5 is 5, 2 times 5 is 10. So that means we would need to multiply by a factor of 5 to move it up. So our final equation would be 5 times 2 to the opposite of x plus 3. It's always a good thing to check either by graphing it in your graphing calculator or doing an XY table to see if you do in fact get the points that was given. Well, the 2 points were at -1 and 0. So if we plug in a -1 to that equation, we would get 5 times 2 to the opposite of -1 plus 3. So that's 5 times 2 to the +1 plus 3, which does in fact give us 13. So that works. And if we plug in 0, we get 5 times 2 to the power of 0 plus 3, which is just 5 times 1 plus 3, which is in fact 8. This one was tricky because we saw one of the transformations, but it wasn't the first transformation that occurs. We knew it moved up 3 units because of the horizontal asymptote. So sometimes if you see the last movement, just reverse it to see what that middle movement would be. So there's our final answer for the equation, y equals. All right, guys, so that's it for 4.2, the graphs of exponential functions. If you have any questions, you know where to find me. See you soon. Bye.